Welcome to Prof.Ahilaa Max, Plus 2 Mathematics, Tamil Nadu State Board Syllabus, Chapter 1, Application of Matrices and Determinants, Video 1:29, 1.4.3, Third Method, Gaussian Elimination Method, Example 1.27 and 1.28. Dear children, let us see the steps to Gaussian Elimination Method. This method can be applied even if the coefficient matrix is singular matrix and rectangular matrix. You please remember that the first two methods, that is matrix inversion method and Cramer's rule, applicable only for non-singular matrices, okay? And it is the method of substitution. Now step 1. Transform the augmented matrix AB of the system of linear equations into row echelon form. Second step, do back substitution. Third one, get the solution. Now what is back substitution? The method of going from the last equation to the first equation is called the method of back substitution. Understood? Fine. 1.4.3, third method, Gaussian elimination method. Solve the following system of linear equations by Gaussian elimination method. The equations are 4x plus 3y plus 6z equal to 25, x plus 5y plus 7z equal to 13, 2x plus 9y plus z equal to 1. Now let us see how to solve this. Remember the step. First we need to convert to the matrix form, then get the augmented matrix, convert to row echelon form, by back substitution get the solution. That is the method. Okay. So what is the matrix form of the system? That is Ax equal to B. A means coefficient matrix, X variable matrix and B the constant matrix. So write it. From the first equation, the first row is coefficients 4, 3, 6. The second equation, the coefficients are 1, 5, 7. So the third equation gives the coefficients as 2, 9, 1 in the third row. The variables mentioned here are x, y, z. And see the right hand side constants 25, 13, 1. Now what is augmented matrix? Our aim is to transform the augmented matrix to echelon form. So augmented matrix A comma B equal to, first write A matrix bar the constant matrix. So row echelon form means we try to keep the first element A11 as 1. So I inspect the first column or the first row. Here I can see 1 in the place A21, that is in the first column. So better I can interchange row 1 and row 2 to make this A11 as 1. So my operation is R1 interchange with R2. So my equivalent matrix is, see, we write the second row in the first row 1, 5, 7, 13. And in the second row we replace by the first row of the previous matrix. That is 4, 3, 6, 25. Third row as it is. Understood? Now next we need to change this 4, 2, 9 as zeros. That is our aim, to make it as row echelon form. So in order to make 4 as 0, I can use this first row as my operating row, that is pivot row. So the operation goes as R2 goes to R2 minus 4 R1. To make this A31 as 0, I should make the operation as R3 tends to R3 minus 2 R1. So that my equivalent matrix is, first row as it is 1, 5, 7, 13. Second row, after making this operation, we get 0, minus 17, minus 22, minus 27. And third row as 0, minus 1, minus 13, minus 25. Yet I need to make this minus 1, that is A32 place as 0. For that I make the operation as R2 goes to minus R2 to make my values simple. Okay, I change the signs of all the R2 values, and to make this minus 1 as 0, the operation is R3 tends to 17 R3 minus R2. Okay, so that after making that operation, I want to make all the signs to be negative. So again I consider the negative of the R3 values what I get. Okay, so the equivalent values are as it is. Now the level best I have converted to row echelon form. Now converting to equations again. So from the first row we get x plus 5y plus 7z equal to 13. From the second row there is no x value. So I start with y value. Okay, 17y plus 22z equal to 27. In the third row there is no x value and y value. So the equation is 199z equal to 398. Now back substituting, go from the last equation. Okay, so from the last equation I can get the value of z as 398 by 199, which is 2. Now I substitute this z value in the previous equation to get the value of y. So my y value is 1 by 17 into 27 minus 22 into, substitute the z value as 2. So I am getting by simplification minus 1. Then from the first equation I can substitute the values of y and z to get the value of x. So my x value is 13 minus 5 into minus 1, the value of y, minus 7 into 2, the value of z. Simplifying, we are getting as 4. So our solution is x equal to 4, y equal to minus 1, z equal to 2. Understood? Very good. Example 1.28. The upward speed v of t of a rocket at time t is approximated by v of t equal to at square plus bt plus c, 0 less than or equal to t less than or equal to 100, where a, b and c are constants. It has been found that the speed at times t equal to 3, t equal to 6 and t equal to 9 seconds are respectively 64, 133 and 208 miles per second respectively. Find the speed at time t equal to 15 seconds. Use Gaussian elimination method. Now given the speed in terms of a function, that is v of t equal to at square plus bt plus c, was t ranges from 0 to 100. We get the following system of linear equations from the clue that when time t equal to 3, 6 and 9, we are getting the speed as 64, 133 and 208 respectively. So our equation, first equation is v of 3 equal to 64. So instead of t, substitute 3. So we are getting 9a plus 3b plus c equal to 64. Similarly, v of 6 equal to 133. So 36a plus 6b plus c equal to 133. v of 9 equal to 208. Therefore, 81a plus 9b plus c equal to 208. Now write the matrix form as capital AX equal to B. Collect the coefficient matrix 931, 3661, 8191 and the variable matrices ABC here. See the right hand side constants. So constant matrix is 64, 133, 208. Now the augmented matrix A bar B equal to, substitute the A matrix and constant matrix. Now I want to make this A21 and A31 element as 0. So A21 is 36 here, A31 is 81 here. In order to make 36 to be 0, using the first row as our pivot row, the operation is R2 tends to R2 minus 4 R1. To make 81 to be 0, R3 tends to R3 minus 9 R1. So our equivalent matrix is like this. Now I inspect the second row, which is getting all the elements negative and divisible by 3. So for simplicity, I make this R2 tends to minus R2 by 3. Next, I want to make this minus 18, that is A32 element to be 0. For that, I use the second row as my pivot row. So the operation is R3 tends to R3 minus 3 R2. Thus I am getting the equivalent matrix like this. Now again converting to equations from the first row, 9a plus 3b plus c equal to 64. From the second row there is no a term, so 2b plus c equal to 41. From the third row there is no a and b terms, so c equal to 1. Now back substituting, use the third equation first. We are getting c equal to 1. Substitute this value in the second equation to get the value of b. So from the second equation, b equal to 41 minus c by 2, which is equal to 41 minus 1 by 2, that is 40 by 2 equal to 20. So with this b and c values, substitute in the first equation to get the value of a. So a equal to 64 minus 3b minus c by 9. Substitute b and c values. So we are getting a equal to 1 by 3. Therefore our solution is a equal to 1 by 3, b equal to 20 and c equal to 1. The problem not yet over. It is asked to find the speed at time t equal to 15 seconds. We are given the equation no, for the speed v of t equal to at square plus bt plus c. So substitute t equal to 15 in this equation, and as we have got the values of a, b, c, we can substitute those values too to get the required speed. So v of 15 equal to, substitute a, b, c values and t equal to 15. So simplifying, we are getting it as 376. Therefore speed at time t equal to 15 seconds is 376. Understood? Very good. Video 1 is to 29 contents are exercise 1.5, first, second, third and fourth problems, solving systems of linear equations by Gaussian elimination method. Stay tuned. Success is ours. Thank you, my dear children.